Okay, so this time round, this is our integral here, okay, and it would make sense to make our substitution to be the letter u equals to what's in this bracket here, okay. It makes sense to do that. If you don't do a substitution, you've got to integrate this, okay, and one of the ways you could do it, as I said before in the last question, is to expand this using binomial expansion and then integrate it, but it'll take a long time to do that, okay. So let's use a substitution, and u will equal what's in that bracket there, okay. But remember, we've got to replace everything, okay. We've got to get rid of all the x's, so we need to replace this x, okay, in this integral. So we've got to think, well, what's x going to equal to? All right, well, when we look at this here, okay, I can easily rearrange this to get x equals, can't I? All I've got to do is, okay, is take that 1 over the other side to make it a -1. So I get u minus 1 equals 3x, and then to get x, I just take that 3 over and divide, okay? So u minus 1 over 3 is equal to x. So my x will be substituted by this, okay? We also got to replace the dx as well, okay? We've got to get rid of the x's. So when I look at this here, I'm going to differentiate it, u with respect to x. So du by dx becomes, well, if I differentiate that there, 3x becomes 3, okay? And the 1 disappears. So then, just like I did before, I could take that dx up there, couldn't I? So I could say, look, du is equal to 3dx, okay, take it up there in times, but I actually want to work out what dx is. So to work out what dx is, I need to take that 3 over then the other side, because we're timesing here, and I take that over, I'm going to be dividing, so that implies that du by 3 is equal to dx. That's what I'm going to replace it by. So therefore, let's do the substitution. My integral will become, so remember now, my x I worked out to be u minus 1 over 3. Okay. My bracket then, well, my bracket will sort of go, won't it? Because I've got this being u to the power 5. And then my dx became du over 3. Okay. Now a couple of things here to make this a little bit easier. What you could do then, notice the bottom, okay, you've got fraction here and a fraction here, and we're timesing. So when you times in fractions, you times the numbers. So 3 times 3 is 9, okay. But what I can do, I can take that outside of the integral, because there's a constant. So 3 times 3 is 9, it's on the bottom. So outside the integral, I can write 1/9. By just taking that out, it's a fraction 1/9. In here then, I've got u minus 1, all times u to the power 5. Now if you prefer, you could write u to the power 5 first, and then the u minus 1 du. And just like last time then, this now is going to be simple. I would now expand that bracket, okay. So you get the integral of u to the power 6 minus u to the power 5. When you times that out, it's du. And then it's easy, isn't it? You just integrate them, okay. So u to the power 6 becomes u to the power 7, add 1, divide by new power. U to the power 5 becomes u to the power 6, divide by 6. Okay, close bracket, and then don't forget the plus c there. Okay, it's important you have a bracket here, because you need to show that you're timesing everything in here by the 1/9, because it's like a factor, isn't it? And yeah, we don't have limits, okay, so remember then the answer, don't leave it in terms of u, the answer needs to be left in terms of x. So then put the value of u back in. So remember, u was equal to 3x plus 1, that's our substitution, okay. So you literally put all that in there, plus a c, and we've got quite a complicated looking answer, but we've done it in a really simple way.